I think this point is easier. I know the x and y coordinate are both positive, so it's going to be easier to plug in to this equation. I won't have to deal with two negative signs. So for x1, I'm going to put 1, and for y1, I'm going to put 2. Keep in mind, it doesn't matter which point you use, you'll still wind up with the same equation. I'm going to multiply both sides by x minus 1. X minus 1 divided by x minus 1 makes 1. So I have x minus 1 times negative 3 halves. I move the negative 3 halves in front of the x minus 1 because we usually list constants outside of parentheses first. I'm going to multiply both sides of the equation by 2. I only need to multiply the negative 3 halves by 2 because this number will be distributed to both terms. However, on this side, I need to multiply 2 to each of these terms. 2 times negative 3 halves is negative 3, and distributing this 2, I get 2y and negative 4. Continuing with distribution, I have negative 3x plus 3 and 2y minus 4 on the right. I'm going to try and solve this equation for y. I'm going to get it in slope-intercept form. Adding 4 to both sides, I get 2y equals negative 3x plus 7. I added 4 because remember, I'm trying to get the y alone. I know we're used to seeing y on the left side of the equation, but this is okay. We can rewrite our equation in the end, with the y on the other side and this on the right. Finally, we divide each term by 2, and we get y is equal to negative 3 halves x plus 7 halves. This is our equation in slope-intercept form. Notice I've just written the y on the left side and this expression on the right side. Here's my equation. There's also a quick check here. We want to make sure our slope is negative 3 halves. Is that what we found before? We can check and see the slopes are both negative 3 halves, so yeah, we at least have this part of the problem right.